50 to 53. And so 52 is simplified. Is 53 simplified? So 53 is also simplified if we are looking at that, right? So on those questions. So going back to your notes that are on page 16, you were looking at these reasons, okay? Now, as we take a look at your other homework questions, you should have been correcting in the back as you were looking at those. And so as you were looking at those questions, here are those answers. The odds were back there, though, that you were looking at. So if we are looking at 27, 29, or 32, 33. So when I look at number 33, as I'm simplifying, this is yesterday's notes, simplifying our radical expressions. So key three things: no perfect square, no perfect factors underneath our radical, underneath that square root. The radical must contain no fractions, and there is no radicals in our denominator. And that's what we're mostly working with today. It's called rationalizing your denominator, okay? So it says a radicand that is a fraction can always be split into two radicals, one in the numerator and one in the denominator. So this was at the beginning of the unit on G1. There were some of you that gave me decimal answers. If you give me a decimal answer, I'm going to mark it wrong when you take your quiz next week, okay? So if you have square root 36 over square root of 49, I want you to find the square root of the numerator and square root of the denominator and leave your answer as a fraction. Same way you start. But you get something like this, the next page down in your notes, and it says, simplify this. And they're going to give you kind of some hints on how we can simplify it. Notice it says the first thing we notice is you have 8 over 50, and so they divided them both by 2 and x. Now we definitely want to divide by the x, right? Because we want x to the second. And the reason we're going to divide by 2 is because now what happens with our two numbers? 8 divided by 2 is 4, and 50 divided by 2 is 25. So those are nice perfect squares. So I can now write it as the square root of 4x squared divided by the square root of 25. The square root of 4, 2, square root of x squared, x over 5. This is our final answer. And you're going to leave it in that way. So as we take a look, there's many ways of doing some of the problems. So do you have your notes? You don't have to do this now. You need to take your notes. Okay. So square root of 144 is going to give us 12. Square root of 9 is 3, but you can simplify this, right? So you don't want to leave it as 12 over 3. You're going to tell us 4. There's a couple different ways with this one. Someone said, can I take the square root of each number? You could. If you did that, you'd have 6 over what? 2. But you still have your square roots. And you have a over a to the second. So remember when we were doing division, we were actually subtracting, and since our larger power is in the denominator, this would actually leave us in our denominator with the square root of what? A to the second. Oh. So 6 divided by 2 gives us 3, and in our denominator, we are going to have over a. I want to show you another way that some students like to think of this one. Could you have divided 36 by 4? Yep. Yes. You would have had the square root of 9, right? And in our denominator, you would have had the square root of a squared, right? Because 3 minus 1. So could you have simplified right away before you take that square root? Because all of that is kind of all under one square root, right? 36 divided by 4 is 9. A to the third, with a divided by a to the third, and you would still get the same answer as 3 over 8. So I don't care which way you look at it and factor it, there's many ways of doing the problem, right? So simplifying. You just can't have any patterns or any of those repeat in numerator and denominator. So if you tried that last one, if you have it, please give it a shot. Square root of 20. I'm going to go what? Nope. With me? I want to go into the second times m to the first, right? Because I'm trying to find the square root of these. So the square root of 25, that gives me the 5. The square root of n squared gives me n. I can find the square root of m to the second, right? Just m, but I'm left with the square root of m. Okay? With the variables. So anytime you have a variable and you're taking the square root, okay, you want to break it down to whatever that x number is to an even power times x to the 1. So if you start with the square root of an odd power, you want to go to an even and 1. And remember that these two have to add to give you that number. So when you are looking at the square root of x to the 11, you want to go with the even power closest to this, which is going to give us x to the 10th and x to the 1st, because we can find the square root by taking half of 10, that gives us x to the 5th, and you keep it as a square root of x. If you want to put the 1 in there, you can, but you don't have to. So if it's a cube root that you're taking, you're going to find something divisible by 3. If it's a fourth root, you want it divisible by 4, and then the other number not divisible by that, okay? So kind of thinking of that. So on the top of the next part, the rationalizing. If you were going to read for us, Evie, please.
When a radicand in the denominator is not a perfect square, you need to rationalize the denominator to make a radical. To do this, multiply the numerator and the denominator by the same radical expression. Choose an expression that makes the radicand in the denominator a perfect square. It may be helpful to start simplifying the original radical in the denominator. Remember, it's not simplified if there's a radical in the denominator.
So they give you two examples. They have square root 3 over square root 7. I cannot have a square root in my denominator. And in order to rationalize this, I want to get rid of that square root 7. So square root 7 times square root 7 is equal to just 7. So I am going to multiply the numerator and denominator by the same square root 7. That leaves me with the square root 29 over square root 49. Some of you at this point will just write square root 7 times square root 7, and you'll put that that's 7 in our denominator. That's fine. In the numerator, it doesn't simplify, it's square root 21. Now, this next one in B, what did they do to the 8 first? They factored 8. How did they factor that 8? They actually factored it as 4 times 2n, right? All over square root 7. So they put this 2 out in front. They didn't show factoring this. They just did that, right? And they said, oh, the square root of 4 is 2, and you're left with the square root of 2n. If I'm going to rationalize the denominator, that means I cannot have square root of 2n. So I'm going to multiply by that exact thing, square root 2n over square root 2n. When I do that, keeping in mind that the square root of 2n times the square root of 2n, that's the same as saying the square root of 2n to the second power, right? And the radical, they undo each other. The square and the square root undo each other, and you are left simply with 2n. So we have, if we are thinking about this, we have 2 times 2n. They didn't show that. That's how they got the 4n. So you still have this 2 out in front that you have to multiply by. But then the square root of 14n, we can't simplify that, so we just leave it as square root of 14n over the 4n. So it's a similar idea to changing fractions in order to get a common denominator. Instead, we want to multiply so that we have a perfect square in our denominator. That is the key to rationalizing, okay? And this just gets kind of ugly. So if we look at the first one, square root 2 over square root 3. I want to multiply both numerator and denominator by something. Ben, what do you think I should multiply both numerator and denominator times? 2. So if I multiply by square root 2, does that get rid of having a square root of my denominator. So what I want to try instead, I do want to multiply by a square root. I want to go square root 3, right? Because square root 3 times square root 3 is equal to just 3. And I'm going to leave it like that. If you want to write square root 9 first and then do it, you could, right? But 3 times 3 is equal to just 3, and in our numerator we have square root 6. So this rationalize square root 6 over 3. So I have square root 5. I'm going to start factoring that square root of 18 because there's a perfect square that goes into it. The perfect square that goes into it, Taylor, is what? 9. So I'm going to go square root 5. And in my denominator, I'm going to put a square root of 9 times 2m. So far, if I'm simplifying this, I have square root 5. Lady, square root of 9 is 3. And I'm left, Josie, with square root of 2m. Yeah. So next, Soren, I'm going to multiply so that I can rationalize my denominator. What would I multiply numerator and denominator by? 2m. By 2m. Close. Actually, the what of 2m? The square root. So keeping that square root. Because if you don't keep the square root, that'd be like taking and multiplying this 3 times this, which we don't want to do. That doesn't help to rationalize it. So you got to keep that square root with it. So once I do that, Owen, and I'm multiplying both of those, in my numerator, what are we ending up with? Look at our numerator.
10m over...
Do you want the square root of 10m?
Yes, square root of 10m.
Okay.
Over 6m.
Because we're taking 3 times. This is going to be just 2m, right? So 3 times that gives us 6m. Oh, but I got m in the numerator and denominator. Can't I cancel those? No, one's the square root. This is not m to the first. This is m. Actually, if we take it out of that square root, it's m to the half, right? And this is m. So we can't simplify it. Yeah. You can do that also. You can do that also, but if you multiply both, numerator and denominator by square root of 18, yeah, that'd be fine if you did that. But some people will multiply by square root of 18m, then it's a lot more work for you. Okay, so you just got to be careful that way. You could do it that way, it's a lot more work. All right, so if we look at that last one, try this one on your paper. See what you can do to rationalize that. I saw this. I'm going to multiply by square root 3. Do you agree?
Yes.
Over square root 3.
Yes.
I had someone tell me that that is the square root of 21f over 9. I could if I was multiplying this out. Okay, so what some of you sometimes are doing is this. This, when you take square root 3 times square root 3, that is just 3. So you can go from this step to here, but if you put 9, you have to keep that square root with it. You cannot just say 3 times 3 is 9 because these are under the square root. It is not just 3 times 3 equaling 9. Those are all under the square root, so you got to be really careful with that. And the numerator is going to stay as square root of 21f. Questions? Okay, is that making sense a little better? Okay. All right, so your homework tonight. So